Hello, everyone. My name is John Adams with Keysight Channel Enablement. Today, I'm joined by Senior Product Manager Vlad Laslau here to talk about Cloud Peak. Cloud Peak is a virtual network infrastructure testing and validation software that's there to make sure that you are always be prepared in the most critical, high or latency critical applications you might find in the future. So one thing to know also is that if you would like to have more questions after this session, please feel free to reach out to Keysight or the distributors listed in the link below. Also, if you would like a demo, please feel free to reach out to Keysight or use the distributor link below to get more help. So Vlad, would you please share your webcam and we can go ahead and move forward.
Hello, John. Hi, everyone. Hopefully you guys can see me. Very excited to be here and to speak about a topic that John described. So we have a very interesting conversation to have about virtual networks, about cloud infrastructure, and about testing the performance of that cloud infrastructure. So we, Keysight, together with our partners, we participated in some Plugfest recently, and we uncovered a lot of interesting findings that I wanted to share today with this community. So with that being said, I have a description of the environment that we tested, and also I have some slides to describe the findings. So what I'll do now, John, and thanks again for the introduction, I'll go ahead and share the screen, and with that, I'll go over the presentation. So can you give me a confirmation, please, that you can see my screen share?
We see your screen, Vlad. Please continue.
Perfect. So what happened in here? Keysight, as part of the ORAN Alliance, we are a member of the ORAN Alliance. We participated in the ORAN Plugfest in the second half of 2021. And in there, with our esteemed partners at Wind River, we done some very interesting testing in the ORAN or cloud infrastructure space. What kind of testing did we do? We wanted to focus on the cloud infrastructure and its behavior when it's running latency-sensitive applications. So you have a bunch of servers running virtualization software. In this case, we are actually speaking about containers and Kubernetes. And we wanted to see how different containers behave depending on NUMA placement, depending on CPU hyperthreading, depending on how big the server utilization is, depending on the traffic patterns. So we did this exercise to understand what is the cloud infrastructure behavior when it hosts latency-sensitive applications, especially for 5G networks, because in 5G, we all know that latency is critical. So with that being said, we used CloudPeak, which is a tool to benchmark cloud infrastructures. Network latency is one of the characteristics that it can benchmark, but it can do CPU, memory, storage, all sort of benchmarking across all sort of clouds. And what are we using CloudPeak in general for? Different companies are using it to compare infrastructure, optimize it, and identify the bottlenecks in the cloud infrastructure itself. So the servers and the software running on those servers. And the test topology that we are discussing today is composed of the system under test provided by our partners. This is a low latency Linux based OS with Kubernetes and containers running on top, everything based on Starling X open source project. And we used CloudPeak to connect with the Kubernetes API to this system under test. We deployed test instances or workloads on top of the system under test, and we measured the latency. And here are some samples of the tests that we've executed. We've run thousands of tests, and we collected close to 500,000 of data points in order to be able to draw the conclusions that I'm about to share with you in the following slides. So with that being said, let's jump into the findings. And at least to me and also to our partners, these were very interesting findings. Some of them were maybe the results were more bigger than we expected. But without further ado, let's go into the results. So what we did, we compared the latency of different applications when they were deployed in a certain server on the same NUMA node versus deployed on different NUMA nodes. What that means with a traditional dual socket server, one application was pinned to one socket and the other was pinned to the other socket. And the difference in performance between these two scenarios was huge. 29% difference in latency, only because a container is running on a CPU versus running on a different CPU. You can see some numbers in here, the average latency going from about 45 microseconds all the way to 58 microseconds. So we were expecting maybe a few microseconds, maybe a few percentage points. This was much, much bigger than we anticipated. And we wanted to signal to the industry, and we did so as part of the ORAN Alliance Plugfest, that it's very, very important to be able to ensure placement for the applications, to configure correctly the placement. Because at the end of the day, the difference, you might say it's only 10 or 13 microseconds. But when the applications communicate very often to one another, this adds up after multiple communications. So this is why we believe this was the most important finding, to ensure that in a cloud infrastructure, you have the placement means to control the application deployment. A second thing that we looked at was how is the infrastructure behaving when it's getting more and more loaded. And for that, we've run some testing that we called noisy neighbors. These noisy neighbors are some aggressive applications in the way they are consuming resources. They are trying to consume a lot of CPU, a lot of memory, to kind of simulate worst case scenario. What happens if the infrastructure is approaching the limit? So with this kind of scenario, we've run three tests. The baseline test is when we had 10 applications running on the same platform. Then we increased that number to 20 applications. And then we went to 10 applications with 10 noisy neighbors in parallel. So basically, this is half server utilization. And the second and the third scenario is almost 100% utilization. But the third scenario is actually worse than the second because it's a very aggressive way of consuming the resources. So in this case, we actually see a very interesting trend that the latency is very slightly improved as the server becomes more and more loaded. And I wanted to give kudos once again to our partners for implementing such a strong infrastructure. What is the explanation for the latency being improved in this scenario? Well, when you only have a few applications and they're exchanging packets randomly, not all the time, the CPU every once in a while goes to a sleep state. And in that case, when it wakes up from the sleep state, it incurs a small delay, a few microseconds. The more loaded the server is, those sleep states are no longer encountered. So the CPU is always active, it's always running. So there is no more delay in processing new packets. So you can see this is why we have run this testing to understand what happens when the server reaches capacity. And you need to understand that an infrastructure needs to be designed with maximum capacity in mind. So this was, again, a very, very interesting finding. Number 3 scenario that we've run was related to CPU hyperthreading. And some people might wonder, well, CPU hyperthreading, it's always enabled, right? Oh, everybody keeps it enabled. It's good for your performance. Isn't that true? Well, yes and no. It actually depends on the application. When we are speaking about network optimized applications, hyperthreading actually has a detrimental effect. With hyperthreading disabled, we had better latency comparing to hyperthreading enabled. If you look at the charts which are moving, and if you look especially at the maximum latency, for example, you can see that maximum latency, as soon as we enabled hyperthreading, the maximum latency goes up by 15%. So that's a difference of close to 40 microseconds, only because hyperthreading is enabled. That's why in an ORAN or cloud, in a 5G environment, most of the vendors are recommending to keep hyperthreading disabled. That won't have a significant impact in the throughput, but it will have a very significant impact in the latency. And 5G latency, this is one of the critical metrics. I'm repeating the same statement again, but this is an interesting finding, and it underlines that it is recommended to keep hyperthreading disabled. Another interesting finding as part of this exercise was to look at the software overhead. So the infrastructure that we tested was composed of multiple servers configured in an active standby role. So this was called a hyper-converged cloud. And we wanted to understand, is there any overhead because a server is acting as an active Kubernetes controller versus a standby Kubernetes controller? And we did the measurement, and the answer is yes, there is an overhead caused by the Kubernetes management services. That overhead in our measurements was pretty small. It was about 4%. When the controller is active, it has a 4% bigger latency, comparing it to be a standby controller. And that's by virtue of running multiple Kubernetes services in parallel with the same applications, with the network optimized applications. So my conclusion, our conclusion from this kind of measurement, the impact is minimal. The impact from a hyper-converged cloud, the extra latency is minimal compared to the benefits of having high availability, of having a primary and backup. Nevertheless, it's important to know if you have a very latency sensitive application, you might want to place it on the standby controller, not on the active Kubernetes controller. And just to put into perspective all the measurements that we've done so far, everything, all the numbers were related to measuring latency within a single server. So only the server, the cloud infrastructure latency numbers were taken into account. But obviously, you also have the physical network latency connecting the cloud elements. And we wanted to compare placement within a single server with placement across different servers. And you can see it's about 2.5x increase, to be more specific, 2.43x. So all the previous differences fade away in comparison to this huge difference. So it's clear to say that if you want the applications to communicate very fast, place them on the same server, not only on the same server, place them on the same NUMA node, make sure that server is a Kubernetes standby controller, and also make sure to disable hyperthreading. When all these conditions are met, this is when you get the lowest latency. And when I say the lowest latency, in our case was about 40 to 45 microseconds. If you compare those numbers with other numbers seen in here, you will see that all the effects add up. So just to summarize the key learnings, we are very proud to be part of the ORAN Alliance, to participate together with our partners from Wind River in this case, in this very interesting PlugFest exercise. There was a lot of lessons to be learned for everybody, and we wanted to share these lessons with the ORAN Alliance, with other companies within the ORAN Alliance, and also with our partners, with Keysight partners as well, and with the broader market. We believe that this type of testing the 5G network, testing the cloud infrastructure, testing for latency, but not only for latency, also other dimensions. We believe all of this is very, very critical to make sure that the 5G networks operate properly, to make sure that a service provider, an operator, can deliver services according to what their customers expect. So, John, this is what I wanted to share from my side. I'm very happy once again to discuss with you and with the team. Please feel free to add anything else if you want.
Okay, thank you very much, Vlad. You can go ahead and stop sharing. All right, thank you everybody for joining us during this live session today. As Vlad stated, we're doing a lot of testing and we love getting through these new experiences with our partners. So for example, even myself, I'm learning a bit more with this LinkedIn Live stuff. So I do apologize for a little bit of, let's say, a visual mishap with a flip, but we did see that fixed. And hopefully we'll be able to facilitate this type of messaging and say outreach of information to you or to partners, to anyone who would be interested in this LinkedIn Live format in the near future. So once again, if you do have questions about Cloud Peak and this topic Vlad discussed, please reach out to Keysight or the distributors below. There is also a demo environment that's waiting and ready for you. And we are looking forward to hear from you. So thank you very much for your time and enjoy your day.
Thanks a lot, John. Thanks a lot, everyone, for joining. Nice talking to you. Bye-bye.